What did you have to have in order to do that? Bravo, sir.
Is it sad that
You had to have a common denominator. Okay? And when you did that, you worked with stuff like this. You started with 2/3 plus a half. And you'd have to figure out what's called that least common denominator, the LCD. Now, there's many different ways of doing it. Sometimes people just multiply the two numbers together and you get a factor. Sometimes that number is bigger than what it needs to be and you have to simplify later. I like to work with the least common because it's just easier to do the work up front. So, what's the smallest next number that both 3 and 2 go into? 6. So what happens here is that you want to get this common denominator of 6. But in order to do that, you have to multiply both terms by something. Now, here's what happens. And this is going to work the same way when we start doing our stuff later on with all of our polynomial terms. How do you multiply, what do you multiply 3 by to turn it into a 6? 2. Now, I got to multiply both the numerator and the denominator. I have to multiply them both by 2 because what's 2 over 2? 1. All you're doing here is multiplying it by some factor of 1 to help change its shape. Same thing here with the half. You multiply it by 3 over 3. So you wind up with 4 plus 3. So 2/3 plus 1/2 is 7/6. Okay? What you're doing is you're working with factors of 1. That's all it is. You're changing the shape to make it easier. All right? Same thing happens when you have these funky terms like we've been working with to get common denominators. As long as you have a common denominator, you can add or subtract. So let me show you. If I look at, oops, I don't worry about that one, didn't turn out as well. If I look at this, 4 over 3x plus 5 over 3x, those guys have a common denominator. Yeah. What is it?
3x.
3x. So what happens here, since they're already common, just put the denominator down. What's 4 plus 5?
2.
9.
21.
9. Guess what? It's 9.
And now you're done with that, or are you?
No.
I can simplify that. What do you get?
3 over x.
3 over x.
You're done. You go through the whole process. Sometimes you'll simplify it, sometimes you won't. Not a big deal. Okay? If I go back, well, when I took the picture, it looked like a plus sign. So if I look at this one, same basic principle, basic idea, but now it's subtraction. But if I look at this, doesn't it already have a common denominator?
Yeah.
So what's your numerator going to be?
2x minus 1. No, that's would you,
Can I simplify that at all?
No.
If I took the 2 out, that's a good idea, but I don't need to. The only reason I'd say I take a 2 out is, let's say the denominator was 2x plus 8. Then I could factor out a 2 and simplify. Does that make sense? But it's good that you're looking for that. That's a good thing to look for. But in this case, we didn't have it, so I don't worry about it. All right?
You just pull it out.
You guys seem to forget that I know how to use a smartboard. I have had a smartboard for going on, it's our 3rd year here? 4th year here, so I had all 4 years here, and so 6 or 7 years now I've had a smartboard. I know, I'm like a light year.
You had smartboards before everyone else.
Because I'm SMRT. So now let's work on the other side.
I think it's just very
Let's start talking about the ones that you have to actually do some work with. So we're going to add these two together. I have 5 over 6x squared plus x over 4x squared minus 12x. And basically, just like we've been doing for the past couple of days, when we had all these weird terms, you're immediately going to go ahead and factor. Okay? Factor your denominators out. In this case here, on the fraction on the left, can I factor anything? No. So I'm just going to rewrite it. What's up, bud?
Couldn't you cross multiply them?
Do you see an equal sign?
No, wait, hear me out here. Couldn't you cross multiply them and then multiply 6x squared by 4x squared minus 12x and make that the denominator and add the two cross multiply things and then factor it? Because that works.
It does work, but the problem when you do that,
What?
I understood every single thing, but why?
what the problem is when you do that, you wind up with a larger term than you need to. You still have to go back and resimplify everything out,
Yeah.
and that gets really messy.
Just a lot more work.
All right. So here's what I've got. We have 5 over the 6x squared plus x over, what do I do on that second denominator? Yeah, take out the 4x, good. Are we okay with that now? Can I do anything right now? What can I do? I can get rid of the x's in this case. In this example, it is completely, totally, perfectly fine to get rid of those x values. Why?
They're objects.
Because they're both multiples and they're on their own fraction. They're already part their own terms. Okay. So this case, in this example, these x values can be simplified. So I'm just going to rewrite this as 5 over 6x squared plus 1 over 4 times x minus 3. Are we okay with that? All right. Now, fraction on the left, we have 2 terms, right? 6x squared. One on the right, we also have 2 terms. 4x minus 3. When you have different numerical things, the 6 and the 4, that's what you look at first. What's the least common denominator of a 6 and a 4? 12. Okay? So here's what we did. I'm going to move this up. I know that my new denominator is going to be 12 for the number. I'll move this over to the side so you can see it. Fraction on the left has an x squared. Does the fraction on the right have an x squared?
No.
So we have to write it down. And then same thing with the x minus 3. By doing that, you're writing down all the terms to make it common. You okay with that?
Over 5?
I haven't gotten to the numerator yet. I just took care of the denominators first.
So you don't worry about all those x's?
Not yet, not yet. So now, if I look at the fraction on the left, it had a 6x squared to begin with, but I got to turn that 6 into a 12. What do you multiply it by then?
2.
So I know I have to multiply the top by a 2, and what else? The bottom by a 2, and the x minus, oops. I also have to multiply it by the x minus 3. See how the denominator here already has a 6x squared, so it already has part of the common denominator. It has the 6 and an x squared. It just needs that 6 to be multiplied by 2, and it also needs the x minus 3. And Clay, this is where you're coming with by going across like that. It does work, but did you see how if we did that to begin with, it's just going to be so much bigger, you'd have to do a lot of factoring and detailing. That's all. All right? So now you multiply that first fraction by 2 times 5 times the x minus 3 plus, well, the other side has a 4 and an x minus 3. How do you change the 4 into a 12? And what else does it need? X squared. So we have 3x squared times the 1. Thank you. You don't have to. I'm just showing it just for so you guys can follow through on this. Now, I want everybody to notice this again because this has been coming up way too much today. You cannot, don't do it, I know. You cannot do anything because of that. What is that? It's a plus sign between a whole bunch of terms. You cannot simplify anything right now. So here's what you do. What's 2 times 5?
10.
Distribute the 10 to the x minus 3. You get 10x minus 30 plus 3x squared. Now, can I rewrite that into a descending order to make it just look nicer?
Yeah.
Okay.
Math kit says no.
I just did it. I just moved it to the front. Is that all right?
No.
I just rewrote it to descending order. Just made it look nice. I simplified, all I did here is simplify the numerator. I distribute combined like terms of the numerator, and I put that all over the denominator. Do not multiply out your denominators. Always simplify your numerators. Usually, there's nothing you can do after that. The 3x squared came from, if I go back to the denominator here, we have 4 and then x minus 3. The common denominator has the x minus 3 already, so I don't need to multiply it by that. It has a 12, so I turn a 4 into a 12. I multiply it by 3, and it needed the x squared, so I multiply it by the x squared. It's the same idea here. I had to multiply the 6 by a 2, and I had to get the x minus 3. You're seeing what other parts it needed. Yeah.
How come this time you don't simplify at the top?
What do you mean? Like FOIL it or anything? Oh, you can look at it, but 3 times negative 30 gives you negative 90. Negative 90 is going to get you to 10. Yeah. Every once in a while you'll come across one. More often than not, you don't. The biggest thing you might come across is like here you might, if this was a 4, you could take out a 2. And you could simplify here. But a lot of times when you're doing your numerators, there's not a lot you can do. But we always write out the numerators, don't worry about the denominator. Okay? Does that make sense?
Yeah.
All right. So try it now when it's not as scary. It's the same process. It's the same thing. It doesn't change up as from the complicated one I showed you to the easy one now. When you have 7 over 5x plus 8 over 3x, notice how both denominators have what in common?
X.
They both have an x in common, don't they? So what's the common or least common multiple of 3 and 5? 15. So what do you multiply 5 by to turn it into 15? What do you multiply 8 by, or excuse me, the 3 by to turn it into 15? 5. See how it's the exact same process? It's the same thing. I wanted to show you the complex to bring it back to show you that it's not that bad. You're figuring out what do they have in common, writing it out, and basically, I don't want to use distributing, but you're making sure everybody has a piece of the denominator. It's like sharing pie or something. Okay?
Use pizza instead. I remember things
Yes,
about
ma'am.
pizza.
Don't share
Okay,
it.
so in the denominator, then you put the LCD and the common denominator.
That is the common denominator, the LCD is the common denominator.
No, like, well, I don't know how to phrase it, like, you put the X in,
Yeah.
and then the LCD, and that's what you do
Yeah.
every time? Okay.
Yeah, you're looking where they have in common, you usually write that down first, and then what's left.
Okay.
What is it?
Okay. Same idea if you're doing subtraction. It's the same basic process when you're doing subtraction. You still need to factor everything out prior to doing anything to figure out what they're going to have in common. What terms do they have in common? All right.
What multiple?
Let you guys write that out. Now, as you start to factor this, x plus 1 that first denominator is plus 2 plus 2. You okay with that?
Yeah.
All right. The second one is going to be plus 2 minus 2. So now when you go to talk about the common denominator, do either of those denominators have anything in common?
Yeah.
They both have an x plus 2 in common, right? Similarly to how this guy, they both had an x in common. They both had that x in common, we wrote it down. Well now, instead of just being a singular monomial, it's a binomial term. They both have an x plus 2 in common. Write it down. What else is left? X plus 2 and x minus 2. So there winds up being 3 separate terms of the denominator. Okay? Think about what you did in the problem before. We had an x and an x in common. We wrote it down. What was left? 3 times 5. 15. It's the same problem.
So is it kind of like thinking about when you're simplifying radicals, like 2 goes in?
Yeah. Similarly. Yes. Okay.
So then whatever's left over goes down there along
Yep.
with.
Yep. So if I'm looking at the fraction on the left, it has an x plus 2 and an x plus 2, but what's it missing?
X minus 2.
Missing an x minus 2. So the numerator becomes x minus 1, or excuse me, x plus 1, x minus 2, minus 2 times what?
It's not missing.
It is missing something. Here it has a plus 2 and a minus 2. The denominator has...
This is so confusing. Can we just use substitution again?
no.
This is so confusing now.
Okay. What's happening here, just again, what do they have in common? They had an x plus 2 on both fractions. We wrote it down. What was left? An x plus 2 and an x minus 2. We wrote it down. Fraction on the left has a plus 2 and a plus 2. It needs the minus 2. Fraction on the right has a plus and a minus 2. It needs a plus 2. All right? And that's what we're filling through. So, again, at this point, all you have to do is your numerator, you multiply out and combine like terms. When you do that, you get, let's see, the x squared minus x minus 2 minus 2x minus 4. And where you guys are going to screw up is this last piece. You're going to forget to distribute the negative to both parts. What's that? I didn't hear you.
So should we remember that not for doing
You should, but you usually forget that. Okay. So you combine your like terms there, and you wind up with a numerator of x squared minus 3x minus 6 all over x plus 2, x plus 2, x minus 2. You can take a look at that numerator and realize you can't factor it. What goes to negative 6 that adds to negative 3? You're done. Yes, ma'am?
Why don't you do the same to the denominator?
What you do with the denominator is you usually leave it in the terms because you can do more things with it. At this point in time, you can tell me my vertical asymptotes.
Oh my God. You're going to make us do that, aren't you?
I might. I know that because if you FOILed out the denominator there, you'd wind up with a large you'd wind up with a third degree polynomial that you'd have to refoil to figure out your zeros, wouldn't you?
Sure.
When you have something like this, you don't know what your zeros are going to be until you write it out. Here you're already there, okay? More often than not, they never bothered messing with the denominator. They always simplify the numerators. Okay. Think back to what we did in 9.2 and 9.3. We talked about graphing. This is a third degree in the denominator, second degree in the numerator, so therefore the denominator has a larger degree than the numerator.
No horizontal asymptote.
You can figure out where your horizontal or your vertical asymptotes may wind up off of something like this, just by doing all that work. There's no need to rework it out, okay?
Can we go over another one like that?
Sure, do this one.
That's not like the last one. Yes, it is.
Yes, it is. It's the same exact thing. It's the same exact principle. The process to which you're solving these problems and simplifying them out, it doesn't change whatsoever. The only thing that changes is the pseudo-complexity of it. Pseudo-complexity. Now, in this case, what's your common denominator going to be? That's all it is. That's it. Notice how there's plus signs in both denominators there? You can't break them apart to say that it's going to be 12 and x, because it's not a monomial. It's a binomial. There's two parts there. These are terms, guys. Those are terms. Those are individual terms. Okay? It's a binomial and a binomial. So your denominator is going to wind up being x minus 4, x plus 3. What's the first fraction missing? Missing an x plus 3. The other fraction is missing. Distribute out. So you wind up with what we're doing here is treat those guys, since you can't factor anything out, that's its own term. X minus 4, x plus 3, those are terms. Those are binomial terms. All right? Stop with the tapping. These are crazy. All right? Obviously, you sit here and you look at this for a second. What gets you 24 to negative 3? Nothing. 6 and 4, 8 and 3. No,
What if we do run into a problem that gives us something factorable?
factor it. Yeah, then you can cross stuff out. Usually, it doesn't happen very often. It doesn't happen that often. What'll happen a lot of times is you might be able to get like a simple GCF, like a 2 or a 3 or something like that. That's usually what winds up happening here. Okay? So, let's make this more interesting.
Oh, crap.
That's just messed up.
I'm gonna put a big no. You're trying to cheat here. You're just supposed to multiply it by the inverse. It just looks funky.
It looks funky, right?
Yeah.
So stop your whining.
Okay.
There's no whining.
Ambulance.
It's the ambulance. Take the ambulance ride out of here.
I thought that was like an actual.
I hate that plane.
Wow, right on cue, am I right?
Now, like you guys are saying, we'll go back to it. Isn't that the same looking thing? It's fraction divided by fraction. Okay? That's a vertically written division problem. We don't like doing fractions, writing fractions out vertically because they look like crap. Isn't this the same thing as saying 2/3 divided by 4/5?
Yeah.
Which isn't that the same thing as saying 2/3 times 5/4?
Yes. Just say yes.
You get 5/6?
Yes.
How many times have you done that problem?
I just made that problem up off the top of my head.
Wait, so.
Nice.
Guys, all this is, it's the same idea, but, well, if you stay awake, you can see more of it. If I look at this, there's two fractions. Okay, there's two fractions.
We flip them, no?
Do you need to do anything to that?
I don't want, I honestly don't
I
want
know,
to do
just
it.
relax. Do you have to do anything to that?
No.
No. There's nothing you can do to that. What can you do to that?
No.
But nothing. And you're dividing it by something you have to simplify. Right? Okay? Work with what you have to simplify first. It's the same process to the other problems. So if I have a 1 over x plus 2 plus a 2 over x, if I'm looking just at this first part, what's the common denominator?
No.
Nothing.
It's both one, so that it becomes X.
X times
Yeah.
X plus 2.
It's going to be x and an x plus 2.
Oh,
Okay.
see, I didn't.
They're both individual terms. There's no factors, there's no nothing. Okay? What does this side need?
X.
An x. So what's 1 times x?
X.
What does the other side need? So simplify that numerator. What do you get? I'm looking at just this part. I'm just looking at this part of the numerator. 3x plus 4. Right. Now, we didn't do anything to this, did we? Okay, so just bring it over. Now take this crappy looking vertical fraction that you guys are all freaking out about and rewrite it horizontally to a division problem that you did yesterday. To a multiplication. Oops, got my pencil. This is the exact same thing you guys did yesterday. It's already factored for you. You write it out. 2 over x plus 2 divided by, now this is going to be the only time that I write it out with the division symbol. I'm automatically, after this problem from here on out, going to automatically flip to the fraction. Flip the fraction. I just want you guys to see what's going on. Remember, I just rewrote that vertical, nasty-looking fraction to the horizontal division problem that you did yesterday. What do you do to that second fraction? You're going to flip it. Whoops. What happens? The x plus 2's can drop out. Your x plus 2's wind up dropping out.
I think this is the easiest thing you showed us all day.
It's not that bad. Ah!
No, there's a plus sign, don't do it.
That's right.
You lied to me.
You took,
Is that why you're yelling during class?
and you're done. There's nothing left that I can simplify out. At this point, Lydia, this is where you were asking about what else could you wind up. If this was like a 6, I can factor out a 2 out of the denominator. But it's not, so I'll do it. Okay. Every once in a while, these problems, the next logical step would be usually maybe a GCF. Okay. Yes, sir?
Out of all of that, you just get a 2x.
Yeah. Sometimes you get 1. It just depends upon the problem. Okay. All right. It's the same exact process as that. Flip the fractions. It's all we're doing. Okay? Let's try an easier one. Easier. You'll see the process again. The process is very, very simple. It just looks weird. Okay? Excuse me. So I have x over 5 plus 4 all over 8 plus 1 over x. Now, a a lot of times I might suggest, since you've got those constants there, put them over 1. Sometimes it's helpful to show that where you're at. So the numerator, what's going to be common denominator between a 5 and a 1?
5.
It's going to be a 5. Are we okay with that? All right. Fraction on the left, it has a 5, so what do I put above it? What do I write down? Just write down the x. Fraction on the left, it needs the 5, right? What's 4 times 5?
20.
I have simplified the numerator's fraction. I do the same thing with the denominator fraction. What's the common denominator going to be? What is it? Remember, you're multiplying. It's just x. So, fraction on the left, does it need anything?
No.
It's an x.
On the left, right.
As long as you know what you're talking about, you're fine.
8x plus 1.
Yeah, 8x plus 1 then. We have alleviated the problem of all common denominators. So now it's just a matter of multiplying by the reciprocal. So you wind up with x plus 20 over 5 times x over 8x plus 1. Notice I just flipped it right away. If you want to rewrite it out one more time with the horizontal before you go to the fraction, before you flip it over, that's fine. You don't need to. Okay. Your final answer then becomes x squared plus 20x over 40x. Oh, sorry. I had it there. But 5 times the 8x plus 4. It's working with the common denominators and multiplying stuff through.
Wait, why don't we distribute the 5?
It's common form not to worry about your denominator.
Yeah, I feel like distributed that on accident on the test.
It's not the end of the world. It's just something that you don't need to do.
Would you like my?
I might give you the frowny, stern face.
Okay.
Does that mean that you do it on all the bases?
So,
Let's do another one.
do it. Do that.
I followed all the addition rules here. Oh, wait. No, wait. Crap. I know I did wrong now.
You guys do 2 plus 25, right? 27?
No, I forgot there was an addition between x minus x plus 2 and the 25.
Yeah, it's B plus. Sorry.
Kid.
Sorry.
I forgot there was.
I didn't know I got it. 25 and 22. I thought x plus 2 was its own term.
Yeah, what happens here is, since you've got your little 1, this part didn't need anything, but the other one needed 5 times 5. That's where I got the 25. Then I combine my like terms to get that x minus 23. Okay. The 2 minus 25. 2 minus 23. All right. Now, what I want you guys to work on here today isn't this. Let me change it a little bit. think it's 45.
Wait, what's that number?
Why don't you take my book,
17. It's a 17.
I know, but it looks like it's high.
You can't figure that's a 17?
Wait, that's a 17? Oh, you're too much.
Yeah, those do those.
Mr. Murphy,
Yeah, but
I
can
said.
you help me on this one? That one was probably the same.
Why did I not?